Okay, let's go back to a motion application problem. So in this particular problem, you've got a particle moving along a straight line, so assuming it's only moving right and left. And the position of the particle is given by this equation, where s is the position and t is time in seconds. First question is find the velocity. So one of the things that we learned before is the velocity is change in position over change in time, which is really the derivative of the position function. So velocity is really the same as the first derivative of the position function. And this one, we can take the derivative pretty easily just using the power rule. Oops. So it would be 3t squared minus 12t plus 9. I want to know what's the velocity at time 2. So I'm just plugging in 2 into the velocity function. And if I do that, I can do that arithmetic in my head, you're going to end up with -3. Units in this problem would be, so this is really change in position over change in time, or ds dt. So the units would be change in position, which is meters, and change in time in seconds. So when we're talking about a particle that's only moving right and left, if we end up with the velocity of -3, it means that it's moving left at a rate of 3 meters per second. Find all the times when the particle is at rest. So it's not moving at all, so we're looking for when is the velocity equal to 0. So I'm going to just take my velocity equation and set to 0. I do notice the 3 can be factored out pretty easily. So it does factor nicely into t minus 3, t minus 1. So the times when the velocity equal to 0 would be at 3 and 1 seconds. The next question is asking, when is the particle moving to the right? So in this case, we are looking for when is the velocity positive. So for this particular problem, we're not going to actually use a calculator. We're going to go back to something from pre-calc. We're going to do a number line, key numbers. And anytime we talk about motion, we assume that time is greater than 0. So I want to know the sign of the velocity function from 0, and it could possibly be changing directions at 3 and 1. So I'm going to split up that velocity function from 1 to 3. And we just want to know when is this going to be positive. So let's just go ahead and plug in these interval numbers into my velocity function. So if I plug a number like 1/2 into this velocity function, the 3 doesn't matter. That's always positive. This first factor will make it negative. This will make it negative, so this is going to be positive. So that means this particle is moving to the right. If I plug in a number between 1 to 3, like 2, the first factor is going to be negative, but this piece will be positive. So a negative times a positive is a negative. So that means this particle is moving to the left from 1 to 3 seconds. And then if I plug in a number like 4, both of these are positive, so this is moving to the right. So what this is saying is the particle from 0 to 1 seconds is going to move to the right, then it's going to turn around and move to the left, and then it's going to turn back around and move to the right again. That's what this little table is showing us. So we can say it is moving to the right from 0 to 1 seconds and from 3 to infinity. Okay, the last question is find the total distance traveled by the particle over the interval. Okay, this question here, total distance traveled, we need to know how many units the particle has moved in this direction, and then add up the units it moved backwards, and add up the units it went forward again. A lot of times people just want to do this, take the position at 5 seconds and take the position at 0 seconds and just take the difference. Now, just for this piece, you can use your calculator just to do the arithmetic. But if I find the position at 5, this is going to be 20. And the position at 0, I'm plugging it back into the original position function here. It's going to be 0. So this is just what's called the displacement from start to end. So that's the difference between starting point and end point. But that does not give me total distance traveled. Total distance traveled is, I want to take into account that it moved forward here and backwards and forwards again. Think about a car. If it moves forward 3 units and backwards 3 units, the displacement is 0, it's still the same place it started, but total distance traveled would be 6 units. So in order to find total distance traveled, not only do you need the position at where you started at time 0, but you also need to figure out the position at all these places where it changed directions, which is where velocity is 0. So I need to figure out the position at 1, 3, and 5. I can go ahead and just plug it back into that position function. And it's not just these positions. What this is saying is we set up here from 0 to 1 seconds, the particle is moving to the right. So it went from a position of 0 to 4, so it traveled a total of 4 units. And then from 1 to 3 seconds, it moved backwards, but it still traveled a total distance of 4 units. Okay, we're just taking the positive value. And then from 3 to 5 seconds, it turned around and traveled a total of 20 units. So your total distance traveled here is the sum of all of these pieces, which would be 28. And we're not going to do this last question.